We are going to start at number 33 now. Okay, so it's saying to identify the domain in the range. Well, the domain in the range is just the way of saying what can't x be and what can't y be. So I know that this one, x can't be equal to 2. Okay, so then I can look at my equations. So remember that the numerator is less than the denominator. So I can find my intercepts from that. Or I can say, okay, if I'm trying to find what it can't be, well, that this has to be at 0. There has to be an asymptote, so it can't be at 0 for that. Or I could have set it equal to it and said 0 equals 4 over x minus 2 and seen that this can't happen. Okay, so I know that 0 would be undefined for that. 34. So this one, my x value, x can't be equal to 2 because that would make it undefined. And my range deals with what's out here. So my range, my y value can't be -1 because remember it's the same on the outside. $35. So on this one, we need to identify the holes, the asymptotes, the x-intercepts, the horizontal asymptotes, and then graph this. Okay, so I need to factor this bottom part first into x minus 3 and x minus 1. So here, I know that those are going to cross out, and I'm going to get it 1 over x minus 1. So automatically that tells me that there's a hole at x equals 3. And now I know that there's an asymptote at x equals 1. In terms of my intercepts for this, my numerator-denominator one, so my numerator is less than my denominator. Okay, so that's going to be at y equals 0, so that's our horizontal. And then our vertical is going to be when we have, well, we already figured that one out because there's an asymptote there. Our intercepts is what I meant. So let's go ahead and graph this. Okay, so my horizontal asymptote is going this way at y equals 0. And my vertical one is going up and down at 1. Okay, so then what I know is x-intercepts, where y equals 0, there's going to be none because of the asymptote. So then I can go and look at my y-intercept, and that's when x equals 0. So when I plug in x equals 0, I get y equals 1 over 0 minus 1. So 1 over -1, so that's -1. Okay, so my y-intercept is at -1, which is right here. And you could kind of make your graph just from that. So from where I intersected, I went down 1 and back 1, so I'm going to go up 1 and over 1. You could also put in another test point if you wanted to, but if it's multiple choice, you don't need to do that. You should just be able to look at it. And then remember that there is a hole at 3, so wherever it hits at 3, I want a big open hole there. Okay, on 36, I have 2 as my greatest common factor, so that's going to give me x minus 3 and x plus 2. Well, nothing's going to cross out or cancel there, but what I know is I'm going to have an asymptote at x equals -2. If I look top and bottom, my numerator is equal to my denominator. Okay, so when that happens, it's going to be y equals a over b. My a value is 2 and my b value is 1, so it's at 2. So my x1 is at -2. That's going up and down here. My y1 is at +2, which is here. I know now that I'm going to be able to find an x and a y-intercept, so let's get the harder one out of the way. The x-intercept when y equals 0. Okay. So my y-intercept is going to be 0 equals 2x minus 6 over x minus 2. Multiply to the other side, and I get 0 equals 2x minus 6. So I get 6 equals 2x. So x then is going to equal 3. But this should be a -3. So at -3, it's going to hit here. So that's 1, 2, 3, 4, 5 down and 2 over. So 1, 2, 3, 4, 5 up and 2 over. And then my y-intercept, when x equals 0, is going to be y equals, I'm going to go ahead and cancel 0 minus 6, 0 plus 2, so I get negative 3. Oh, I just did that with that one. This one should have been 3. I was right before. So this should have been a positive 3 going here. Sorry. And this one is actually our green dot right there. Okay, so switching around our green and red. So this one should be green up here. And our red dot is 1, 2, 3, 4, 5 over and 2 down. So I'm going to go 1, 2, 3, 4, 5 back and 2 up. And it's going to look like that. It's away from the axis a bunch on that one. Sorry that one was kind of a terrible explanation. Okay, simplifying each of these. So you're multiplying straight across on these. So I'm looking to factor these first. So I have 9a squared. On the bottom, I can take out 18a squared, and I'm left with a minus 3. Is that right? Why can't I do mental math? 54 divided by 18 is 3, yes. Okay, and then up here I can take out a 6 and I get a minus 3, and this is a plus 2. So go ahead and cancel things out first. So these are alike. My a squareds are alike. The 9 goes into 18 twice, and then 2 is going to go into 6 3 times. So I'm going to have 3 over a plus 2. It also asks for the excluded values. So my excluded values would be here, 0, 3, and negative 2 from those. 38 is asking the same sort of question. We're multiplying these. So this top one is going to be p plus 9 and p minus 9 over 8. This one's going to be 8, and then p minus 4 and p minus 9. Okay, so things that are going to cancel out. The 8s are diagonal. The 9s are diagonal. So what I'm left with is p plus 9 over p minus 4. My restricted things that I can't have are 4 and 9. The next ones are division. Okay, so remember we have to flip and multiply by the reciprocal. These ones you have to do a little bit more factoring for. So the top one, it has to multiply to negative 27, and then it has to add to 6. Well, what's going to do that is positive 9 and negative 3. So then I'm going to go 3r squared plus 9r minus 3r minus 9. Greatest common factor is 3r, r plus 3. Take out a negative 3, get r plus 3. So the top part is going to be 3r minus 3 is your first parenthesis, r plus 3 is my second one. Then I'm going to do the denominator of this. Same thing, what multiplies to negative 24 and adds to 21. Oh, sorry, it needs to multiply to 3 times 24. So what multiplies to negative 72 that adds to 21. So if you don't know that, you can make a factor tree, remember, of that, of things that give you 72. So like you could start at 1 and say 1 and 72, 2 and 36, 3 and 24. And that's going to be your winner on that. Okay, so you're going to go with a positive 24 and a negative 3. So you're going to do the same thing there, where you get 3r squared plus 24r minus 3r minus 24. Greatest common factors here is 3r, and you're left with r plus 8, negative 3, and you're left with r plus 8. So the bottom is 3r minus 3 and r plus 8. So remember when we're dividing that we have to flip and multiply by the reciprocal on this. So the reciprocal with the greatest common factor is r minus 1 and r minus 1. I'm running out of time here, so I'm going to quickly go through those and those, these and these. So my answer is r plus 3 over are plus 8. And if it wants to know your excluded values, you're setting the denominator to 0.